Hello everybody, I'm Ankur Edkie and I'm the CEO and co-founder of Murf AI. 5 years ago, we founded Murf AI because we believe that voice is humanity's most natural interface and will become the primary way we interact and engage with technology. And today, we are taking the biggest leap in that direction. We are launching Murf Falcon, the consistently fastest, most efficient text-to-speech API built to power the next generation of voice interfaces. With advances in large language models and expressive voice synthesis, voice interfaces are evolving beyond simple command execution. They can now sustain natural dialogue, understand nuance through contextual reasoning, and take intelligent action based on conversation history. These capabilities mark the shift to voice agents, systems that don't just respond, but actively assist, adapt, and accomplish tasks through conversation alone. We're already seeing this in customer service. Voice agents that never put you on hold. They understand your issue, navigate your account, and resolve problems on the spot. Voice agents can transform how we learn. Instead of delivering static lessons, they engage with you in real time, answer questions as they come up, and make learning interactive. They can even adapt to your learning style. If you love sports, they might even explain concepts through sports metaphors. And voice agents can reach people anywhere. In regions with limited internet access, voice agents can connect with people through simple phone calls, delivering weather alerts, health guidance, and critical updates in their own language. That's the promise of voice agents. And that's the future we are building toward. To get there, a lot of layers need to come together. Turn-taking has to feel seamless. Reasoning has to get sharper. Speech-to-text needs to be robust. But one of the most critical layers of voice agents is text-to-speech, the layer where everything comes alive. Everything else, the models, the infrastructure, the routing, stay behind the scenes. Speech is what users actually hear, experience, and remember. It defines how natural a conversation feels. When the name is mispronounced, users notice. When there's a pause that lasts too long, they disconnect. When the voice lacks emotion, the whole conversation breaks. That's why text-to-speech layer has to be exceptional. It needs to pronounce words accurately, sound expressive, and respond in real time like a human. Also, it needs to switch between languages as effortlessly as people do in the real world. From a business standpoint, it has to do all of this efficiently, managing latency, keeping costs low, and scaling to tens of thousands of requests across the world. That's where Murf Falcon, our new ultra-low latency text-to-speech API, comes in. Let me show you a quick demo. I'm going to speak to the Falcon voice agent powered by the Falcon API. Small twist, Falcon knows it's launch day, and Falcon in this demo tries to keep things really casual. Hey Falcon, what's up?
Hey Ankur, all good, just, chilling in the cloud. Heard today's a big day. You're launching me, right?
Yes, that's the plan. People are listening to you right now. Why don't you tell everyone what makes you so special?
Oh man, all this attention's kind of making me nervous. Anyway, here's the scoop. I'm a text-to-speech API built for voice agents. I run at about 55 milliseconds model latency and around 130 milliseconds time to first audio in production. Basically, I can get back to you faster than you can say, get back. And yeah, speak like 35 plus languages. I can even switch between them mid-sentence. Comprende?
Nice. Let's put that multilingual ability to the test. Can you say something for our Spanish audience?
Claro que sí. Puedo hablar en más de 35 idiomas, cambiar entre ellos sin problema y mantener el mismo estilo natural en todo momento. Por ejemplo, puedo pasar del español al inglés así de fácil, sin perder el flow. Pretty smooth, huh? So, what other language do you want me to, flex in?
Let's switch to a language I can speak in. आप latency को कैसे consistent रखते हैं?
Edge deployment multiple countries में होने की वजह से latency हर जगह low रहती है. इससे data residency भी ensure होती है.
You use the term data residency. Can you break that down for me in super simple terms?
Sure. Data residency just means your data's kind of a total homebody. It stays right where it belongs. No long distance relationships with servers in other countries.
That's awesome. Thanks, Falcon. I'll take it from here.
You got it.
Well, that was Falcon talking about Falcon. Now, earlier I used two phrases to describe Falcon: consistently fastest and the most efficient. Let's dive deeper into each of them. What do I mean by consistently fastest? Most text-to-speech model latency numbers look impressive in a lab, but they rarely hold up in production. In reality, latency depends on many factors. Let's break it down. Broadly, there are three basic components to the time it takes for your text to reach back to your servers as audio: model latency, application latency, and network latency. Most providers quote only the first component, their model latency. Unfortunately, this is generally unverifiable, and for most state-of-the-art systems, accounts for less than a third of overall observed latency. Fortunately, there's an easy way to verify these claims yourself. Let me show you. We tested some of the most popular TTS models out there. To do that, we used API-ping.io. It's a third-party geo-distributed API relay that sends the same request from multiple edge locations and measures the timing at every stage. We measured time to first audio. That's the time from sending a request to receiving the first frame. It's the real-world measure users actually care about. Let's take a look at one TTS API. On paper, you might see a promised latency of around 75 milliseconds for this API, but in production environments, the numbers vary. Let's test this on API-ping.io. From California, time to first audio is actually about 200 milliseconds. From London, it's about 228 milliseconds. From Mumbai, it's around 549 milliseconds. And from Sydney, it's around 339 milliseconds. So the fastest response time in production is 2 times slower than what's claimed on paper. And depending on where the call comes from, it can be up to 7 times slower. We saw this variation in pattern across multiple text-to-speech APIs. And we set out to fix that with Murf Falcon. Falcon was designed with a lightweight architecture, custom built for voice agents. It uses a compute-efficient proprietary neural architecture that outperforms much larger systems in context awareness while delivering the speed benefits of a smaller model. The result? Murf Falcon delivers a model latency of just 55 milliseconds. More importantly, Falcon delivers a time to first audio of 130 milliseconds in production environments. But we did not stop there. To keep this performance consistent across geographies, we have deployed our infrastructure around 11 strategic regions worldwide. These include several data centers in US, along with Canada, the United Kingdom, Germany, Japan, India, UAE, South Korea, and Australia. So whether you're deploying here in San Francisco, or whether your customer is calling from Mumbai or London, you will consistently experience the promised time to first audio. Now let's take Falcon for a spin on API-ping.io. When we test Falcon's time to first audio from different parts of the world, it consistently stays below 130 milliseconds. From California, we see a latency of 124 milliseconds. From Oregon, it is 108 milliseconds. From London, it's about 112 milliseconds. From Mumbai, it's 111 milliseconds. From Sydney, it's 107 milliseconds. That's pretty much consistent across the world. When we ran this test across regions, sending multiple API calls in each of them, we found that in nearly 90% of locations, Falcon was consistently faster than every other TTS model out there. That's why we call Murf Falcon the consistently fastest TTS API across geographies. Let me show you what this latency actually feels like with another demo. I'm going to play a rapid fire round of questions with a voice agent powered by Falcon. The agent asks, I'll answer, and we'll see how fast the conversation flows. You'll see Falcon's latency on screen for every response. How many questions we get through before time's up doesn't just depend on how quickly I speak. It also depends on how quickly Falcon can respond. Here we go.
Hi, I'm your rapid fire quiz master. So, are you ready?
Let's go.
Let's start easy. What's the capital of Japan?
Tokyo.
Correct. Warming up, huh? Next, how many months have 28 days?
1.
Tricked you there, didn't I? All 12 do. Which country has the most time zones?
US.
Well, that was wrong. It's France. Which planet has the most moons?
It's Saturn.
Correct. Saturn it is. History twist. Which country has the most pyramids?
Egypt, I guess.
Surprise, it is Sudan. Here is a fun one. Which country's national animal is a unicorn?
Oh, I know this. Scotland.
Bingo. Tech trivia. What was the first song sung by a computer?
Daisy Bell.
Correct again. What was the first computer virus called?
Creeper.
Correct. Okay, time's up. You got 5 questions right.
Oh, now that was fast. And Falcon consistently delivered a sub 130 millisecond time to first audio for all those questions with model latency of 55 milliseconds. Another key factor that affects latency is concurrency. As the number of calls go up, most systems begin to slow down. With Murf Falcon's enterprise plan, latency stays consistent, even at 10,000 calls. Now let's look at the second term I used to describe Falcon, the most efficient. When you deploy voice agents in production, inefficiencies show up in speed, language accuracy, concurrency, or costs, and you're forced to make trade-offs. Some text-to-speech APIs deliver natural prosody, but come with high latency or high costs. Others are faster, but support only a handful of languages. Murf Falcon's all-round efficiency breaks that trade-off cycle. If you are a voice agent builder looking to scale globally, you need your agent to support multiple languages. Switching to different TTS players for different languages is very inefficient. Falcon supports over 35 languages, offering more extensive coverage than many other low-latency text-to-speech models. And Falcon is natively fluent across every language. We benchmark Falcon's voice quality across multiple languages, comparing it with other text-to-speech models using the voice quality metric or VQM. VQM is built specifically for voice agents. It is a unified score that measures how natural, accurate, and reliable a voice sounds in real-world production. It goes beyond asking, does it sound nice? And instead asks, does it say the right thing in the right way across tricky real-world inputs? Voice agents often communicate critical information such as prices, health metrics, IDs, and timelines. Misreading even a single digit or unit can create confusion, or in some cases, serious errors. The voice quality metric combines 5 dimensions: naturalness, numerical accuracy, domain accuracy, multilingual accuracy, and contextual accuracy. Each of these measures is normalized on a 0 to 1 scale, then weighted and combined to form the overall score. To make this benchmark meaningful, we tested across several languages using a dataset of more than 3,000 sentences. Across this benchmark, Falcon leads on the voice quality metric, outperforming other low latency text-to-speech APIs. But voice quality alone is not enough. For voice agents, voice quality and latency must work together for a conversation to really feel human. When we plot voice quality metric against latency across different models, Falcon consistently falls in the most efficient quadrant, combining high naturalness with ultra-fast latency. With most other models, you have to make a choice: good voice quality or low latency, but rarely both. Murf Falcon is one of the most accurate text-to-speech APIs available, with a mean pronunciation accuracy of 99.38% across languages. Our purpose-built phonetics layer ensures precision, even with challenging inputs, phone numbers, medical terms, or addresses. With Falcon, you get natural, precise speech that responds in real time. Another important factor when it comes to language is one that often gets overlooked. That's code mixing. Code mixing is when people switch between languages within the same sentence or conversation. That's how real-world conversations are today. It happens across all languages. People mix in a native word here, a word from a different language there. It's just how we talk. Falcon is best in class when it comes to handling code mix sentences efficiently. Let me show you an example. I'll talk to an e-commerce support agent that uses Falcon as its TTS layer. It speaks Indian English and Hindi, and you'll notice how it handles code mixing. It also pronounces complex details like phone numbers, addresses correctly. Hi, could you help me with the status of my order?
Sure. Could you please share your order number?
Yeah, it's 354-98233.
Got it. 35498233, right? Just a moment. Okay. So your order was dispatched yesterday and it should reach by Saturday evening.
Got it. I wanted to visit your store. आपके nearest store का address बता सकते हैं?
बिल्कुल प्लीज अपना पिन कोड कंफर्म करिए.
हाँ, 400051.
गॉट इट. एक सेकेंड. आपका नियरेस्ट स्टोर है फ्लैट नंबर 9, श्री सिद्धिविनायक दर्शन, वीर सावरकर मार्ग, बांद्रा ईस्ट, मुंबई.
Perfect, thanks.
Is there anything else that I can assist you with?
No, that's all.
Have a great day.
That's our best-in-class multilingual model ready for the real-world conversations. Falcon is built with the same multi-native technology that powers Murf's second-generation models, which provide explicit control over locales down to the phonemes. So when it switches languages, it doesn't carry over unwanted accents. This helps the same voice stay consistent and sound fluent across languages, even during code mixing. Because of this architecture, choosing Falcon means choosing one efficient model that scales across languages seamlessly. Falcon is also built to be deployment efficient. Because it's lightweight, it is incredibly easy and efficient to deploy anywhere. This architecture allows us to offer data residency across 11 geographies worldwide, with the flexibility to add as many as required. Deploying locally solves two key problems. First, compliance. Your data stays within the country, meeting regulatory requirements. And second is performance. Reduced network hops means lower and more consistent latency. For organizations that need even greater control, Falcon can also be deployed on premises. You can run it entirely within your own environment, behind your firewall on your own infrastructure, while maintaining the same performance and scalability as the cloud version. The final factor that makes Falcon incredibly efficient is not just in performance, but also in cost, is its price. Thanks to Falcon's compute efficient architecture, we've been able to bring down processing costs significantly. We're offering Murf Falcon at an unmatched price of 1 cent per minute across all plans. That's at least 30% cheaper than the closest alternative and up to 4x more efficient than competing models. The text-to-speech layer typically makes up 30 to 50% of a voice agent's total running costs. So optimizing that layer can make your operations dramatically more efficient. To make this easier to visualize, we built a tool that measures and compares the total cost of running voice agents. It includes all key components: speech-to-text, LLM, and text-to-speech. Let's look at a few examples from this tool. If you are building the highest quality voice agent with the best LLM and STD models available, and your average call runs about 10 minutes, you'll see around 30% savings when you use Falcon as your TTS layer compared to the next closest API. And if you're building a balanced model where your LLM and STD layers are optimized and everything else remains the same, your savings could go even higher, up to 70% with Falcon. When you consider both cost and performance, Murf Falcon stands apart. At just 1 cent per minute, it's the most cost-efficient text-to-speech API with no trade-off in latency or quality. Latency efficient, language efficient, deployment efficient, and cost efficient. That's why we call Falcon the most efficient text-to-speech API in production. We know that building and deploying voice agents is still new territory for many. After half a decade of building, testing, and deploying voice models in production, we have seen just about every challenge there is. And that's why we plan to be right there in the trenches with you. Our support team is available 24/7 with an average response time of under 3 minutes on chat. Our startup incubator program has already drawn thousands of applications. It's our way of helping early stage builders get access to premium voice technology. As part of the program, you'll get over 2,000 hours of free API credits to get started. And for everyone joining the session, we want to make it even easier to begin. Your first proof of concept is on us, with 2,000 plus hours in free API credits. Falcon is the consistently fastest and the most efficient text-to-speech API out there. It delivers best-in-class performance across languages, combining great latency with exceptional voice quality, and offering data residency across multiple regions, all at an unbelievable price of 1 cent per minute. Thank you for joining us, and I hope you love using Falcon as much as we love building it.